Calculate the energy required to change 800 grams of ice at 0 degrees Celsius into steam at 100 degrees Celsius. Specific heat capacity of water is 4,200 joules per kilogram per Kelvin. Specific latent heat of fusion of water is 334,000 joules per kilogram. Specific latent heat of vaporization of water is 2,260,000 joules per kilogram. Solution: we have ice at 0 degrees Celsius that is converted to steam at 100 degrees Celsius. We will move on to draw the heating curve in order to know the stages that are involved for this transformation. That is temperature in degrees Celsius against time. So we have ice initially at 0 degrees Celsius. That is at this point here. So from ice at 0 degrees Celsius, we will have water at 0 degrees Celsius here. Then after that, from water at 0 degrees Celsius, the temperature of water will rise to 100 degrees Celsius. So that is the temperature of water at 100 degrees Celsius, exactly at this point here. So from water at 100 degrees Celsius, we need to move to steam at 100 degrees Celsius. That is a phase change since it does not involve change in temperature. So this point here, we have ice at 0 degrees Celsius. This point here, we have water at 0 degrees Celsius. This point here, we have water at 100 degrees Celsius. And this point here, we have steam at 100 degrees Celsius. All right. So in between here, we'll have ice and water. Here we will have water, and here we will have water and steam. So clearly we have three stages. This is stage 1, stage 2, and stage 3. For stage 1, we have ice at 0 degrees Celsius that converts to water at 0 degrees Celsius. So that is a phase change. We are going to use the formula Q is equal to mLF. Okay, so that is Q is equal to the mass times the specific latent heat of fusion. Okay, we are using fusion here because it is a process of melting. So Q is equal to the mass of the ice times the specific latent heat of fusion of water. The mass of the ice is given in the question as 800 grams. So if you convert that to kilograms, that is supposed to give you 0.8 kilograms. Multiply this by the specific latent heat of fusion of water is 334,000 joules per kilogram. So 0.8 times 334,000 is 267,200 joules. Moving on to stage 2. For stage 2, we have water at 0 degrees Celsius converted to water at 100 degrees Celsius. So that involves a change in temperature. Therefore, we can say for stage 2, Q is equal to mc delta theta. Q2 is going to be equal to the mass of the water, the specific heat capacity of the water, times change in temperature. Q2 is equal to the mass of the water is going to be 0.8 multiplied by the specific heat capacity of water is 4,200 multiplied by the change in temperature. Water is changing from 0 degrees to 100 degrees. So the change in temperature will be 100 minus 0. We can say Q2 is equal to 0.8 times 4,200 times 100. So Q2 is equal to 336,000 joules. Moving on to stage 3. Stage 3 is we have water at 100 degrees Celsius that is converted to steam at, so that is a phase change. So if it is a phase change, we're going to say for stage 3, we're going to say that Q is equal to mLV, okay? The mass times the specific latent heat of vaporization. We are using latent heat of vaporization because the third phase involves boiling. So we're going to say Q3 is equal to the mass of the water times LV. Q3 is equal to the mass of the water is 0.8 kilograms times the specific latent heat of vaporization of water is 2,260,000 joules per kilogram. Two million 260,000. So Q3 is equal to 0.8 times 2,260,000. That is 1,808,000 joules. So if we want to know the total energy that is required for this transformation, it will be Q1 plus Q2 plus Q3. What is Q1? Q1 is 267,200 joules. 267,200 joules plus Q2 is 336,000 plus Q3 is 1,808,000. If you do the addition, you'll have 2,411,200 joules. Calculate the time taken for water of mass 900 grams, initially at 32 degrees Celsius, placed in a refrigerator that extracts heat at a rate of 1,200 watts to become ice at minus 20 degrees Celsius. Specific heat capacity of ice is 2,100 joules per kilogram per Kelvin. Specific heat capacity of water is 4,200 joules per kilogram per Kelvin. Specific latent heat of fusion of water is 334,000 joules per kilogram. If a current of 5 amps was operating the refrigerator, what is the voltage in the circuit? So we will break down this problem. It is a problem that involves thermal heat and some knowledge on the electricity. So what we do know for now is we have water that is initially at 32 degrees Celsius that is placed in a refrigerator which extracts heat at a rate of 1200 watts to become ice at minus 20 degrees Celsius. So basically the temperature change is from 32 degrees Celsius to minus 20 degrees Celsius. So what we're going to do is we're going to draw a cooling curve to see the stages that are involved. Solution. First, let's draw the cooling curve. It is going to be a cooling curve because we are losing heat. The refrigerator is extracting heat from the water in order to turn it to ice. Okay? So this is temperature in degrees Celsius, and we have time on the x-axis. At the initial phase, we have water, let's say here, that is at 36 degrees Celsius. So if water is initially at 36 degrees Celsius and heat is extracted from it, its temperature will fall. So we're going to illustrate that as a negative slope. So let's say from 36 degrees Celsius, it comes to 0 degrees Celsius. Okay, so that is water at 0 degrees Celsius. That is here. From water at 0 degrees Celsius, we're going to transit to ice at 0 degrees Celsius because there has to be a phase change. So this is ice at 0 degrees Celsius. And from ice at 0 degrees Celsius, if the temperature continues to fall, we will have ice at minus 20 degrees Celsius. So as you can see, this is how the cooling curve is to be drawn. Initially, we have water at 36 degrees Celsius that loses its heat to become water at 0 degrees Celsius. Then from water at 0 degrees Celsius, if heat continues to be extracted from it, it becomes ice at 0 degrees Celsius. So ice at 0 degrees Celsius continually loses heat to become ice at minus 20 degrees Celsius. So this whole process involves 3 stages, as you can see. This is stage 1, this is stage 2, and this is stage 3. Let's first try to know the quantity of heat that is involved. Then we will move on to answer the question. For stage 1, that involves a change of temperature. As you can see, water at 36 degrees Celsius becomes water at 0 degrees Celsius. So there is a change in temperature, meaning that we're going to use Q is equal to MC delta theta. So that is Q1 is equal to the mass of the water times the specific heat capacity of the water times change in temperature. So the mass of the water that is given in the question is 900 grams. That is 0.9 kilograms. Multiply by what is the specific heat capacity of water. The specific heat capacity of water is 4,200 joules per kilogram per Kelvin. Multiply by the change in temperature. The temperature falls from 36 degrees Celsius to 0 degrees Celsius. So that is 36 minus 0. Okay, it will be the initial temperature minus the final temperature. So that is 0.9 times 4,200 times 36. Q1 is 136,080 joules. Moving on to the second stage, we have water at 0 degrees Celsius that is converted to ice at 0 degrees Celsius. So this involves specific latent heat of fusion since it is a freezing process. For stage 2, the formula that we're going to use is Q is equal to M times the specific latent heat of fusion. So that is going to be Q2 is equal to the mass of the water times the specific latent heat of fusion. So what is the mass of the water? It is 0.9 times the specific latent heat of fusion is given in the question as 334,000 joules per kilogram. The answer that we'll have for that is 300,600 joules. Moving on to the third phase, we have ice that is at 0 degrees Celsius that becomes ice at minus 20 degrees Celsius. So that involves a change in temperature. For stage 3, we're going to use Q is equal to MC delta theta. So that is to say Q3 is equal to the mass of the ice times the specific heat capacity of ice times the change in temperature. The mass of the ice will be 0.9 kilograms multiplied by the specific heat capacity of the ice is given in the question as 2,100 joules per kilogram per Kelvin. Multiply by the change in temperature for the third phase is from ice at 0 degrees Celsius to ice at minus 20 degrees Celsius. So that will be 0 minus minus 20. 0 minus minus 20. So that is 0.9 times 2,100 times 20. That is 37,800 joules. So if we want to know the total quantity of heat, that will be Q1 plus Q2 plus Q3. Q1 is 136,080 plus Q2 is 300,600 plus Q3 is 37,800. So if you add that up, you have 474,480 joules. So going back to the question, it wants us to calculate the time taken for water of mass 900 grams, initially at 32 degrees Celsius, that is placed in a refrigerator that extracts heat at a rate of 1200 watts to become ice at minus 20 degrees Celsius. We have been able to know the total amount of energy that was extracted from the water in order to become ice. And here we are given the power. So we can be able to find the time. Okay? So if we can remember the equation that the quantity of heat is also equal to the power times the time, then to find the time, we divide both sides by power. So this will cancel this. Therefore, we can say time is equal to the quantity of heat divided by the power. The quantity of heat is 474,480 divided by the power is 1200 watts. So 474,480 divided by 1200, you get 395.4 seconds. Okay, so that is the total time. If we want to convert that to minutes, we divide it by 60. We will have 6.59 minutes. So the question also states that if a current of 5 amps was operating the refrigerator, what is the voltage in the circuit? We are given current and we know the power here. So we know that power is current times voltage. Power is equal to current times the voltage. So if we want to find the voltage, we divide both sides by current. So this will cancel this. That is to say, the voltage is equal to power divided by the current. The power is 1200 watts divided by the current is 5 amps. So 1200 divided by 5 is going to be 240 volts. An electric heater of resistance 44 ohms connected to a 220 volt source is used to supply heat energy to ice of mass 6.6 kilograms initially at minus 10 degrees Celsius until it becomes water at 90 degrees Celsius in a total time of 73.2 minutes. Determine the specific latent heat of fusion of the ice. Specific heat capacity of ice is 2100 joules per kilogram per Kelvin. Specific heat capacity of water is 4200 joules per kilogram per Kelvin. Solution. From the information given, we have ice initially at minus 10 degrees Celsius that is being converted to water at 90 degrees Celsius. Okay? And a heater is used to facilitate that. So we want to know the specific latent heat of fusion, okay, LF, of the ice. The first thing we will try to do is to find ways of calculating the total energy that is involved in the conversion of ice from minus 10 degrees Celsius to water at 90 degrees Celsius. So let us try and draw the heating curve. That is temperature in degrees Celsius against time, let's say in minutes. Initially, we have ice at minus 10 degrees Celsius. That is at this point here. So when heat is supplied to the ice, what we expect is a rise in temperature. So we will have from ice at minus 10 degrees Celsius to ice at 0 degrees Celsius. Okay? That is 0 degrees Celsius of ice. This is ice here, and this point here is also ice. So from ice at 0 degrees Celsius, ice will convert to water through melting, and there will be no change in temperature. So from ice at 0 degrees Celsius, we will have water here at 0 degrees Celsius. Then from this point where water is at 0 degrees Celsius, the temperature of water can rise to 90 degrees Celsius. So that is water here at 90 degrees Celsius. A quick recap, we have ice here at minus 10 degrees Celsius. It will first be converted to ice at 0 degrees Celsius here. So ice at 0 degrees Celsius will turn to water at 0 degrees Celsius here. And from there, we have water at 0 degrees Celsius that will increase its temperature to water at 90 degrees Celsius. So basically, there are 3 stages of this process. We have 1, 2, and 3 here. We will first move on to calculate the total energy that is involved. So beginning with the first stage. For the first stage, that is from ice at minus 10 degrees Celsius to ice at 0 degrees Celsius. So since it involves a change in temperature, we will say Q is equal to mc delta theta. So more specifically, that will be Q1 is equal to the mass of the ice times the specific heat capacity of the ice times the change in temperature. So Q1 is equal to the mass of the ice given in the question is 6.6 kilograms. The specific heat capacity of the ice is 2100 joules per kilogram per Kelvin. So that is mass of the ice 6.6 kilograms times the specific heat capacity of ice is 2100 joules per kilogram per Kelvin times the change in temperature during the first stage of the process is going to be the final temperature minus the initial temperature. So that is 0 minus 10. So we can say Q1 is equal to 6.6 times 2100 times 10. Q1 is equal to 138,600 joules. Moving on to the second stage. The second stage, we have ice at 0 degrees Celsius that is converted to water at 0 degrees Celsius. So this is a phase change, and during a phase change, we have to use the specific latent heat. And here, since it is a melting process, it is the specific latent heat of fusion that we have to use. So for the second stage, we will use the formula Q is equal to the mass times the latent heat of fusion. So specifically, that is Q2 is equal to the mass of the ice times the specific latent heat of fusion. We can say Q2 is equal to the mass of the ice will be 6.6 kilograms times LF, because we don't know the specific latent heat of fusion. It's not given in the question. So Q2 is equal to 6.6 LF. Now we will move on to the third stage. The third stage, we have water at 0 degrees Celsius that is converted to water at 90 degrees Celsius. For the third stage, we will use Q is equal to MC delta theta, because there is a change of temperature of the water from 0 degrees to 90 degrees Celsius. So we can say Q3 is equal to the mass of the water times the specific heat capacity of the water times the change in temperature. So Q3 is equal to the mass of the water will be 6.6 kilograms times the specific heat capacity of the water is given as 4,200 joules per kilogram per Kelvin. 4,200 times the change in temperature will be 90 minus 0. Okay, the final temperature minus the initial temperature. That is the final temperature minus the initial temperature. So Q3 is equal to 6.6 times 4,200 times 90. Q3 is equal to 2,494,800 joules. So if I want to know the total energy, that is Q total, that will be equal to Q1 plus Q2 plus Q3. So what is Q1? Q1 is 138,600 joules plus what is Q2? Q2 is 6.6 times the latent heat of fusion. Okay, we don't have an exact value for it. 6.6 LF plus what is Q3 is 2,494,800 joules. So that is the Q total. But how can we know the total energy that is involved in this situation? If we should go back to the question and read it, we are given resistance, we are given voltage, and we are given time. So this tells us that we can be able to know the total energy that was involved. We know that the quantity of heat is also given as the current times the voltage times the time. Okay, but the current is not given. We know that from the formula, voltage is equal to the current times the resistance. So if I want to find the current, I will divide both sides by the resistance, right? So this will cancel this. Therefore, the current is equal to the voltage divided by the resistance. So if I take this and then I substitute it here in the place of I, what will I have? That is going to be Q is equal to I is V all over R, then multiply by V, then multiply by T. So that is the quantity of heat is equal to V times V is V squared divided by R multiplied by T. So which means we can use this as a formula or an equation to find the total quantity of heat that is involved in this process. So in the place of Q total, we can use V squared multiplied by T divided by R. So this is equal to 138,600 plus 6.6 LF plus 2,494,800. Going back to the question, the resistance is 44 ohms, the voltage is 220 volts, the time is 73.2 minutes. Voltage is 220 volts, so it is squared. We have to square that, multiply by the time is 73.2 minutes. So if you convert that to seconds by multiplying it by 60, you will have 4,392 seconds. So divided by the resistance given in the question is 44 ohms. So this is equal to, we can add up the 138,600 with the 2,494,800. 138,600 plus 2,494,800, that is 2,633,400 plus 6.6 LF. So 220 square is 48,400. Multiply this by 4,392 divided by 44. So this is equal to 2,633,400 plus 6.6 LF. 48,400 multiplied by 4,392. The answer that you have, if you divide by 44, you will have 4,831,200. So this is equal to 2,633,400 plus 6.6 LF. So by collecting like terms, you will say 4,831,200 minus 2,633,400. This is equal to 6.6 LF. 4,831,200 minus 2,633,400 gives 2,197,800. This is equal to 6.6 LF. To find the specific latent heat of fusion, I will divide both sides by 6.6. So this will cancel this. 2,197,800 divided by 6.6, that is 333,000. So this is equal to LF. Therefore, we can say that the specific latent heat of fusion of the ice is 333,000 joules per kilogram. If we want to express that in standard form, we can say the specific latent heat of fusion is equal to 3.33 times 10 to the power 5 joules per kilogram. Thank you very much for watching this video. See you soon in our next video.